Hello everyone, welcome to Smart Sessions from Smart Interviews. Today we are going to solve swapping nodes in a linked list problem from LeetCode. Before we start solving, I recommend you to pause the video here and come up with your own approaches. Let's start. Let's say we are given this linked list. Along with this, k value is given, k is equal to 3. Now what do we have to do is, we'll have to swap the kth node from the beginning and the kth node from the end. That is, we don't need to even swap the nodes, we just need to swap the values of the nodes. For example, if I number this 1, 2, now third node from the beginning is 9, third node from the end is 7. We just need to swap these values. So now after swapping, the linked list is going to look like this. So this is what the question is. How do we solve this? Simple approach is, we'll have to locate kth node from the beginning, let's say this is our first step. Second step, we'll have to locate kth node from the end. Then we simply swap the values of these nodes. That's it. These 3 steps and it will be solved. First step, how do we locate the kth node from the beginning? Straightforward. We'll start at the head and we'll move k minus 1 times to reach the kth node from the beginning. But what about second step? How do we reach the kth node from the end? We can't traverse a linked list from backwards, right? It's a singly linked list, so we can't traverse from backwards. So what do we do? How do we locate this kth node from the end? Okay, one idea is, we can't traverse to the kth node from the end, but the same node is at some position from the beginning. We can traverse from beginning to this node, but for that we'll have to find out what is the position of this node from the beginning. How do we do that? Can we do something by observing the positions here? For example, if k is equal to 3, the position of the third node from the end, from the beginning, is 6. Let's say if k is equal to 2, from the beginning it's going to be 7. If k is equal to 4, from the beginning it's going to be 5. So from these values, can we observe something? Okay, let's say if k is equal to 3, how do we get this 6? One thing we can do is 8 minus 3 plus 1. This gives us 6. K is equal to 2. 8 minus 2 plus 1. K is equal to 4. 8 minus 4 plus 1. Now here we get 6. We get 7 here. We get 5 here. This is what we wanted. So this is turning out to be working in each and every condition. Now, if we generalize this, how do you write it? What is 8? What is 8? The number of nodes. So we can write it as number of nodes in the linked list minus this 3, 2, 4. These are values of k. So number of nodes minus k plus 1. So this one is going to give us the position of the kth node from the end if we are traversing from the beginning. So now, if we find out the position of the node from the beginning, we can simply start at the beginning again, traverse to its node, right? So first thing, we'll locate the kth node from the beginning, we'll store its value. Second thing, we'll traverse to the kth node from the end by starting from the beginning. We'll store its value, we'll swap these values. That's it. Before we start coding it up, I recommend you to implement this approach on your own. Let's start. First thing we require is number of nodes in the linked list. So I'll declare a count variable initialized to 0. Then I'll take one more pointer, let's say current, initialized to head, to traverse in the linked list. While current not equal to null, I'll simply increment the count for every node. Then I'll move the current pointer forward. With this, we'll have the length of the linked list or number of nodes in the linked list. Next, we'll have to locate the kth node from the beginning. Further, let's say we'll initialize our current to head. Then we'll use a for loop. Initially we are at position 1, so int I is equal to 1, I is less than k, I plus plus. We'll move our current forward. Now current is at the kth node from the beginning. Now we'll have to store this reference of this node in some other variable. So let's say node 1 is equal to current. Now we'll have to locate the kth node from the end. For that, first we'll have to find out the position. So position is equal to count minus k plus 1. Next we'll do the same thing. We'll have to travel till that node, but instead this will be position. We'll take some more pointer, node 2, to store the reference of the kth node at the end. Now we'll have to swap it. So I'll take a temporary variable, store node 1's value in it. Next, store node 2's value in node 1. Then we'll store temporary value in node 2. In the end, we'll simply return the head. Okay, we just missed to reinitialize the current to head. That's it. Let's submit it. Accepted. See you in the next video. Thank you for watching. Please like, share and subscribe for more such content.